The true ending of the universe. The future of the universe will not end with a big bang, nor will everything be swallowed by black holes. The real ending of the cosmos is far stranger than any sci-fi movie or novel you've ever seen or read. I'm not joking. This conclusion comes from serious calculations made by scientists using rigorous physical formulas. You might think something this bizarre is incredibly far off and irrelevant to us, but in fact, the clues to this ending are already hidden in the sun, the moon, and the stars we see every night when we look up at the sky. Right now, it feels like these stars will always be hanging there in the heavens. But have you ever seriously wondered what would happen if one day they all vanished completely? What would the universe become? And I'm not talking about hundreds or thousands of years from now, but tens of thousands, even billions of years into the distant future. By that time, not only will every star have gone out for good, but even time itself may cease to have meaning. Even more astonishingly, the very physical laws that we now take for granted might stop working altogether. Sounds extreme, doesn't it? But don't worry, I'll walk you through it so you can witness for yourself what the ultimate fate of the universe really looks like. Hello, and welcome to the world of the universe. To be honest, we are living in one of the luckiest eras in cosmic history. The universe right now is filled with bright, glowing stars, like a grand and luxurious light show, completely free for us to enjoy. But there's something you may not have noticed. The universe wasn't always this lively, and even more unsettling, it won't stay this lively forever. Stars, in a strict sense, are a kind of cosmic luxury. Why? Because they burn hydrogen, an element that was created all at once when the universe was born. After that moment, no new hydrogen has been added. Every single star received its supply of fuel during the universe's birth, and the amount of fuel it got determines how long it will live. In other words, the lifespan of every star has been predetermined since the beginning. Back in the 1930s, an Indian-American scientist named Subramanian Chandrasekhar made a shocking discovery. He found that a star's final fate is determined from the moment it's born. You don't need to look at its brightness or how many planets it has, just its mass. That's the only thing that matters. Take our sun, for example. It's a medium-sized star. In its old age, it will expand into a red giant. That part is well known. But what few people realize is that the Earth won't be swallowed up right away. Instead, it will be pushed outward into a more distant orbit due to the sun's intense radiation, eventually becoming a lifeless, lonely planet. Later, the sun will gradually shed its outer layers into space, leaving behind a small, ultra-dense core. Scientists call this a white dwarf. But the truly dramatic endings belong to the massive stars, the really heavy ones. These stars end their lives in spectacular explosions known as supernovae. At the moment of explosion, they release more energy than all the stars in the Milky Way combined. Some of these stars' cores collapse instantly into what we call neutron stars, objects so dense that a spoonful of their material would weigh over 1 billion tons. And some stars are even more massive and wild. When they explode, their cores become so dense that they warp the very fabric of space, creating the most terrifying thing in the universe, a black hole. If we could witness the death of such stars up close, it would be the most awe-inspiring and horrifying sight in the cosmos. Think again about all those twinkling stars we see. Who would have thought their ultimate fate could be this extreme? But here's what's even more chilling. The death of stars, no matter how dramatic, is just a minor prelude to the universe's final act. The truly bizarre events start after all the stars have gone dark. At that point, the only celestial objects left will be black holes. Now, most people know a bit about black holes. They think of them as terrifying objects that suck in everything around them. But here's the strange truth. Black holes don't actually go out of their way to devour things. They can sit quietly for tens, hundreds, even thousands of billions of years, doing absolutely nothing. They're called black because their gravitational pull is so strong that not even light can escape. But what many people don't know is that black holes aren't eternally black. They can evaporate and eventually disappear. That might sound mysterious or even unbelievable, but it's scientifically true. The universe's true end, Stranger Than Fiction, Part 2. Everyone knows Stephen Hawking. He discovered that black holes aren't truly black. They actually emit energy. This phenomenon was later named after him, Hawking radiation. To put it simply, the vacuum of space near a black hole constantly gives rise to countless pairs of particles. Sometimes one particle falls into the black hole, while the other escapes. The escaped particle carries away a tiny bit of the black hole's energy. But don't get the wrong idea. This process is unimaginably slow. The larger a black hole is, the slower it evaporates. For example, that supermassive black hole at the center of our galaxy? Scientists estimate that it would take around 10 cease-years to evaporate completely. That's vastly longer than the 13.8 billion years our universe has existed so far. In other words, for the vast majority of the universe's future, the main characters will be these extremely dull, lonely black holes, drifting silently in the darkness, doing absolutely nothing. Occasionally, they might swallow a stray asteroid or white dwarf like a cosmic snack, but most of the time they just float, cold, still, and ghost-like, the loneliest entities in the universe. What's even more eerie is that when a black hole finally evaporates, there's no explosion, no flash of light. It disappears gently, quietly, without a sound or trace. When the last black hole in the universe vanishes, there will be no noise, no leftover signs, just an utterly empty, silent cosmos. You might think this is the final ending, but I'm sorry to tell you, the end of the black hole era isn't even the strangest part yet. What comes next is far more bizarre, hundreds of times more unsettling. Many believe that once black holes disappear, the universe will be truly empty. But that's not entirely true. Even if it looks deserted, there are still some fundamental particles left, like protons and electrons. You might think these tiny particles are insignificant, but they are the building blocks of all atoms and all matter. For a long time, scientists believed that protons were stable and could last forever. But in the 1970s, two brilliant physicists, Howard Georgi and Sheldon Glashow, developed a grand unified theory and derived a stunning conclusion. Protons might not be stable after all. They might decay on their own, just extremely slowly. Scientists estimate the lifespan of a single proton could be around 10 ppor years. That's 10 million trillion years. It's almost impossible to comprehend, but the universe has time. Given enough time, even the rarest events will eventually occur. So in the far, far future, the final protons in the universe will slowly begin to decay and vanish. At that point, not a single complete atom will remain. The universe will be reduced to a nearly perfect vacuum with only the faintest trace of radiation. Can you imagine that scene? A cosmos without atoms, without stars, without galaxies, not even the most basic particles. That is the true end of the universe. But wait, you think it ends there? Absolutely not. The weirdest part hasn't even begun. Here's where things start to truly puzzle scientists. We often talk about vacuum as if it's simply an empty space, but that's not what it means in physics. In reality, a vacuum still contains energy fields. What seems empty to us still hides invisible, untouchable forces. And here lies the most critical problem. The vacuum of our universe may not be in its most stable state. What does that mean? Think of it like a small ball temporarily resting on a hillside. It looks fine, but a slight disturbance could send it rolling down into the valley below. Scientists suspect our universe's vacuum is just like that, unstable and perched precariously. This is called a false vacuum. If that's true, then things get terrifying. All it would take is a random quantum fluctuation, some tiny event somewhere in the cosmos to push part of the vacuum into a more stable state, known as the true vacuum. This transition is called vacuum decay. Once it happens, the bubble of true vacuum would expand at nearly the speed of light, swallowing everything in its path. The old universe would be erased instantly. The most dramatic part? This transformation isn't an explosion. It isn't a collision. It comes with no warning. It's simply a silent rewriting of the physical laws in every corner of the universe, instant and absolute. In other words, every rule we now know. The true end of the universe, Part 3. Take gravity, electromagnetism, even the way atoms form. Everything we now take for granted could be completely rewritten. In this new vacuum state, atoms and any complex structures might not even be allowed to exist. Time itself might not exist at all. This means that wherever the new true vacuum bubble spreads, even existence itself might lose all meaning. You might think, this sounds way too far-fetched to ever worry about. But the most chilling part is this. Scientists say vacuum decay could happen anywhere, anytime. It might begin in a distant corner of the universe, or even inside a particle right in front of us, without any warning, without any sign. But don't panic. The probability of such an event is incredibly low. Still, given infinite time, even the most unlikely things eventually happen. And here's the real twist. Once the old universe is completely erased, that newly born vacuum bubble could potentially give rise to an entirely new universe. Yes, theoretically speaking, our own universe may have been born from the remains of a previous one. The cosmos may be in a constant cycle of birth, destruction, rebirth, and destruction again, an eternal loop. Strange, isn't it? But what if, one day, the universe exhausts even its ability to reboot? You might wonder, what's left at that point? Scientists tell us that the universe would become truly empty, cold, silent, and completely still. But even in such an utterly barren vacuum, there's still one thing that never stops: quantum mechanics. Sounds complicated? It's actually simple. At the tiniest scales, space itself never stays completely still. It continuously flickers with random fluctuations. Even in a universe with absolutely nothing, space still trembles. And scientists discovered something extraordinary. If you wait long enough, these quantum fluctuations could randomly create anything. And I mean anything. From a grain of sand to a drop of water. Even a fully formed, thinking human brain. That's not a joke. A complete brain, capable of thought with memory and awareness, could theoretically pop into existence out of empty space. Physicists call this bizarre phenomenon a Boltzmann brain, named after the 19th century physicist Ludwig Boltzmann. He proposed that in a truly random universe, given enough time, even the most improbable events must eventually happen. In the infinitely distant future, this isn't just possible, it's almost certain. Even more bizarre, scientists believe that these spontaneously appearing, fully aware brains, complete with memories, might outnumber the brains formed by natural evolution. What does that mean? It means that in the distant future, most minds that exist may not have any real origin. They would simply flash into existence and then vanish. Boltzmann brains appearing from nothing. If that's true, it completely overturns our understanding of existence and consciousness. And if the universe has stopped evolving, and the only remaining activity is the random birth of fleeting consciousness, what does time even mean anymore? In fact, scientists believe that time doesn't exist independently. It depends on change and difference. When the universe reaches a state of total stillness, no change, no distinction, then time itself may no longer exist. In simple terms, at that point, time wouldn't end, nor would it keep flowing. It would simply lose all meaning. The universe would become a place with no past and no future. After hearing all of this, you might suddenly feel how tiny and insignificant humanity is in the face of such a cosmic scale. Think about it. Our entire civilization has existed for only a few thousand years, but everything we've just discussed unfolds over trillions, quadrillions, even more unimaginable spans of time. From that perspective, humanity is like a blink of an eye, maybe even shorter. But then comes an oddly profound realization. Despite being so small and short-lived, humans somehow developed the wisdom to understand all this. The universe spent all this time, from the birth of stars to their final extinction, from the formation of black holes to their evaporation, just to produce a species like us, capable of observing, thinking about, and even predicting its fate. In a way, it feels like the universe staged a grand performance, and we humans just happened to arrive at the exact right moment to witness it. Perhaps we are even the only audience. We were born into a golden age, surrounded by shining stars, not too early, too late, just in time to see the best part of the show. And what's more, we understand the plot, and we can even guess what might happen next. Is that luck or something more? Maybe the true meaning of our existence lies in our ability to comprehend the universe and ourselves. The final destiny of the cosmos may be, at least in this fleeting moment, we live in a time when we can understand these things. We may not be able to decide the end of the universe, but we can choose to see it.